If you happen to know what the graph of f of x looks like, then how do you sketch the graph of f of x plus c? You move it up an amount of c. What about f of x minus c? Left by c, right by c. And so there's another one which we discussed in WADs without writing anything because we didn't, I mismanaged time. And that's, what should happen if you multiply a function by a negative? What should that do to the graph? Should probably flip it. That seems like something reasonable. Which direction should it flip it? Should it flip it so that x values change or y values change? The y values, right? Because f of x is the y value. It should be like a vertical flip. If you know the graph of f of x, you can get the graph of negative f of x by flipping over the y-axis. If you know the graph of f of x, you can get the graph of f of negative x by flipping, no, I said x-axis and not y-axis. If you want to get the graph of f of negative x, you flip over the y-axis. Everyone feel okay with that? So let's, I know it says skip, but I think I'll do it anyway. So provided here are the graphs of, is the graph of f of x equal to x cubed minus x plus 1. There are two copies of it. So if I want to sketch the graph of f of negative x, what do I need to do? Flip over the y-axis, like it says. And you do that, so this little downward hump will become a downward hump on the other side. This upward hump will become an upward hump on the other side. Do something like that. So there's the graph of y equals f of negative x. What if you want to sketch the graph of negative f of x? Flip it over the x-axis. So this point will stay fixed. And I've got a graph that looks something like that. Everyone feel okay with that? And maybe I'll just ask a quick question, though it's a silly question to ask. Are both of those graphs the same? So it makes a difference which one you do. So let's do a few examples of putting all of these together. And there's a particular order that you should do in putting these things together, and we'll say it maybe explicitly in just a little bit. So let's try to sketch the graph of negative x plus 3 quantity squared plus 4. And let's try to graph it by performing the correct moves one at a time. And I'll propose this. So if you start with the graph of y equals x squared, which, yeah, let's do that. So if there's the graph of y equals x squared, how do you get the graph of negative x squared? Flip it over the x-axis. So to get the graph of negative x squared, you flip this graph over the x-axis, giving you that. And maybe just to avoid confusing myself, wait, the flip that's happening is definitely vertical. It's over the x-axis. Now that we know what the graph of negative x squared looks like, how can you get the graph of negative x plus 3 quantity squared? Move left by 3. Yeah. So the graph will now look something like this, where I moved left by 3. So that'll be negative 3 comma 0 is this point. Cool, but I really want the graph of negative x plus 3 quantity squared plus 4. What does that plus 4 do to the graph? Moves it up by 4. So this vortex point will now be at negative 3 comma 4. How do people feel about that? That seem okay? So I dealt with the individual ingredients in a particular order. First I dealt with this negative sign out front. Then I dealt with the plus 3 and then the plus 4. Do you think that order was necessary? Let's see what happens if we do things in just some random order. So let's see on the board what happens. So apparently there needs to be a vertical flip and then 2 translations. So starting with the graph of y equals x squared, what does that look like again? It's a U-shaped parabola shaped thing. And let's do the same transformations but in a different order. This time let's do the translations first and then we'll do the flip, just to see what it looks like. So first let's translate left 3 up 1. Sorry, left 3 up 4, right? And now let's flip that vertically and see what it ends up looking like. Is that the same graph as we had on this projector right now? No. So apparently the order does matter. And let's try to figure out which one of these is actually correct. And let's do it by thinking about what these functions are at each point. When you shift it left by 3 and up 4, how does shifting left by 3 change the function? It adds 3 to the x. So this should be, I'll take this formula and I'll replace all the x's by x plus 3's. And then what does going up by 4 do? Changes the y. So it adds 4 to the output. And then what does flipping over the x-axis do? It multiplies the whole function by a negative. So this is now the graph of y equals, I'll multiply the whole function by negative 1. X plus 3 quantity squared plus 4. Let's see, that simplifies to negative x plus 3 squared minus 4. Aha, so that's the function we've actually graphed when we did this, which is not the function we wanted. So there is an important correct order to do these manipulations in. If you want to sketch the graph of y equal to plus or minus f of plus or minus x, a function like that, the order you want to do the transformations in is, this podium is still just tragic. There's not actually a room on this campus that I like. This one I think I hate the least. So first you should deal with whatever's out in front of the function, just like we did before. You should deal with the translations second. Does it matter whether you go left first or up first? Does that make a difference? No, you get to the same place in the end. So those, I'll just label them both as second. And then you should deal with whatever's in front of the x last. So I think what I'd like you guys to do, or maybe I'll give you guys a choice. I'll give you guys 2 choices. So we'll do one of those 2, and I'll talk through it, and then either I'll just talk through it, or you guys will do it, and then we'll come together. How many people would rather see an example with absolute values done? How many people would rather see an example with square roots done? All right, the square roots have it. So let's do 14, and now there's another choice that you have to make. Either you do it or I do it. How many people want me to keep talking for a little bit? How many people would rather just walk it out on their own? Okay, those of you who would rather just walk it out on your own, do it. Don't listen to me for a few minutes, and then we'll come together. I stand by my rule of you're not actually allowed to bring earplugs to my class, but you don't have to listen all the time. So let's talk through it. So let's try to go from the graph of the square root of x to negative the square root of negative x plus 3 plus 1. And so let's even just there's the thing we want to go at. And let's decide what order we want to deal with these things in. So according to that thing on the board, what's the first symbol there that I should try to deal with?
The negative.
The negative, and the leftmost negative, in fact. So let's deal with this first. What's the next thing I should do?
Plus 1.
Do the plus 1, and maybe I'll do the plus 3 at the same time. Right. You can do them both at the same time. I'll save myself a little bit of time by doing that. And then finally, you have to deal with the minus 1?
Minus x.
Yeah. The minus in front of the x. So we'll deal with that one last. So let's go for this one at a time. What does that negative, so starting with the square root function, we know what that looks like. There's y equals square root of x. So the first step then is going to be graphing y equals negative the square root of x. How do you go from the graph of the square root function to the graph of negative the square root function? I need to flip it over something. Flip it over the x-axis, or if you're like me and you easily get confused between which is x-axis and which is y-axis, you're going to do the flip that changes y values. You're going to flip it vertically. So there's the graph of negative the square root of x. So apparently now I need to deal with the plus 3 and the plus 1. So let's sketch next to the graph of y equals negative the square root of x plus 3 plus 1. And both of those just amount to some shifts, right? How should I shift it?
To the left. To the left.
Left by 3, up by 1. So let's do that. Left by 1, 2, 3, up by 1. And you know what? Maybe I'll just check one thing. I'll check that the y-axis is in a believable place. I'll check the y-intercept is in a believable place. What do you get when you plug in x equals 0 to this? Do you get something positive or negative? I think you get something negative because it's negative the square root of 3, which is like 1.7 something, I think. 1.8? It's bigger than 1. So negative 1.8 plus 1. Yeah, that's negative. So I know that the y-intercept is going to be negative something. Oh, Chris. Fortunately, I gave myself enough space that that's not a disaster. What's the last thing I need to do? Deal with the negative sign in front of x. And what is that going to do to the graph? It'll flip over the y-axis. It'll do the flip that changes x values. So negative the square root of negative x plus 3 plus 1. So I just put a negative sign in front of the x. So that will now, this point will now be at 3, 1. Still have that same y-intercept. Where is it? How do people feel about that? That seem okay? those of you who just did it on your own instead of listening, you got something similar in probably about half the time? Cool. So, there's one last transformation that I want to introduce. Yeah, let's be honest. It's all listed as like 4 more transformations, but it's really just maybe 2. So instead of just thinking about things like, did anyone not get the notes that I handed out before class started? Excellent. So we've established that if you want to sketch the graph of a function that looks like this, given what the graph of f looks like, well, you can do so by using the transformations we established, well, I guess on Friday, in a particular order. But that's not everything, right? Probably we can understand what happens when you multiply a function by a constant, multiply an x value by a constant. And let's build up, well, let's state some intuition, and then we'll see if this intuition actually works. So, let's try to graph f of 2x and 2 times f of x for these particular functions, for this particular function. So let's just understand what functions we even want to graph. We'll have a computer graph them, and then we'll see what they look like. So if we want to sketch the graph of f of 2 times x, I'll replace all the x's with 2 x's. That'll be 2x minus 1 quantity squared minus 4. And 2 times f of x will be 2 times, parentheses matter, x minus 1 quantity squared minus 4. So let's have a computer generate the graph of f of x, 2 times f of x, and f of 2 times x. And we'll think about what transformation is needed to achieve that. So, oops, not this. So let's plot f of x and f of 2x for side by side so we can see how they compare. Let's sketch the graph of x minus 1 quantity squared minus 4. And let's also sketch the graph of 2x minus 1 quantity squared minus 4. And let's just do a quick sanity check. That's too small. I want to make this bigger. Are those actually the 2 functions that I want to graph right now? Okay. I can't be trusted with successfully hitting keys on a keyboard. Oh, by the way, you should all make sure to double check that I've entered your grades correctly. Because out of 80 students, I guarantee I've screwed up at least 1 grade. So let's take a look at these 2 graphs. Well, you've decided to simplify one of them, which is annoying, but that's okay. So this blue one is the original graph. Here is the graph after you replace x with 2x. And tell me, how would you go from the blue graph to the pink graph? What does it look like has happened? Yeah.
Actually, I think one is missing 2. Multiply the whole thing by. You went 2. I checked the top one. For like what you wrote down with 2 times, and then parentheses x minus 1 squared, and then on 1.
I think it was simplified.
Decent. Okay.
Yeah. So.
Okay. Well, I can't really see it that well anymore. So.
Yeah, Wolfram Alpha decided that it would be simpler if it like were those 2 terms in the opposite order, which it's in a square, so it doesn't matter.
Oh, okay. All right. Awesome.
So yeah, here's the graph of the original function, the pink one. Nope, the blue one is the graph of the original function. The pink one is after I've multiplied the x by 2. How does it look like those 2 differ?
Like stretches vertically.
It looks kind of like it stretched vertically, but like a vertical stretch, like this has a like a bottom about there. The bottom is a little bit to the right instead, so it's not just something vertical going on. Yeah.
It condenses while maintaining the same y changes it?
Yeah, so it's actually something horizontal that's happening. So all the y values are staying the same. The x values are getting squished in. And if you imagine taking this blue carbon, squeezing it inward, while keeping the y-intercept fixed, that's what's going on. All the x values are being reduced by a factor of 2. So let's see if we can draw a picture of that. So the graph of y equals f of x looked something like that. The graph of f of 2x looked similar, but it was steeper because all the x values got squeezed inwards. And that's generally true. Whenever you want to sketch the graph of y equal to f of c times x, how do you do that? You divide all x values on the graph by c. And that's what happened in the previous one, right? All of the x values got halved. Everything moved half of the way towards the origin, towards the y-axis, which is why the y-intercept stayed in the same place. What do you think will happen when I multiply the whole function by 2?
Doesn't it get longer, technically?
Yeah, it should get like longer somehow. It should get stretched out. And I'm doing something to the function itself, so it'll probably be y values that should change. And let's see what happens. So let's go back over here, and let's add the third one to the graph that you wanted added earlier. 2 times x minus 1 quantity squared minus 4. I guess I can make this like bigger. I don't need the rest of the screen. Are those the 3? So is that f of x, f of 2x, and 2 times f of x in order? Okay, good. And let's see. The blue one is the original function. The red one is f of 2x, and the gold one is 2 times f of x. And let's see, does it look like if I just took the blue one and stretched it vertically, I would get the gold one? Yeah. And that's what happens in general. If you want to know what the graph of a constant times f of x is, you start with the graph of y equals f of x and multiply all y values by that constant c. Feel pretty okay about this? And the same ordering condition matters. First, you should deal with whatever the function is multiplied by, including the negative. Second, you should deal with how much you should shift it. And then you should deal with whether or not you need to divide the x values by anything. So let's see this in practice. So let's try to sketch the graph of negative 1/2 x minus 2 quantity squared plus 30. Let's try to sketch the graph of that thing. So, I mean, I don't know, what's an elementary function that you can start with if you want to graph that? X squared. X squared. So let's start with the graph of, well, I'm going to hedge my bets and start with, give myself a little bit more space. The graph of y equals x squared, I know what that looks like. It'll look something like that. And now, according to the instructions above, what symbol in this list of symbols should I deal with first?
Far left negative.
That negative sign? Yeah. So that means the next thing I should graph is negative x squared. What should that graph look like? Or I guess, how do I get that graph?
Flip it on the y-axis.
To flip it over the y-axis. And I have these grid marks, so I'll try to like respect them. What's the next thing I should do?
Subtract theta 2 from parentheses.
Yeah, deal with the negative 2 in the parentheses. Okay, let's just deal with the minus 2 in the parentheses. What does that minus 2 do?
Move to the right.
2 to the right. So next is negative x minus 2 quantity squared. So it'll move it 2 to the right. So this vortex will wind up there. Cool. What should I deal with next?
The 1 plus 3.
The 3. And we could have dealt with the plus 3 in that single step, but it looks like I have enough space that I'm okay. I can do it in 2 separate ones right now. So let's go up by 3. Sketch the graph of negative x minus 2 squared plus 3. So this vortex is going to travel up by 3. 1, 2, 3. All right, and what's the last thing I need to deal with? The 1/2. So the last step is negative 1/2 x minus 2 quantity squared plus 3. And let's write down this in words. What is that 1/2 going to do? Yeah, so let's see. Let's actually follow the instructions right here. So in this step, all x values will be divided, Gesundheit, by that constant. So divided by 1/2. What's division by 1/2 the same as? Multiplication by 2. So in reality, all x values will be multiplied by 2. So, right, we noticed before that when you multiply all the x values by a constant, it looks like the graph compresses inwards, but that's because that constant was bigger than 1. If you compress by a factor of 1/2, that's really stretching by a factor of 2. So let's do that. Let's even track this point. So that point was at 2, 3. So where is that point going to be after I do that transformation? Yeah. 2 times 2 is 4, and the y value stays in the same place. So it'll wind up at 4, 3. 1, 2, 3, 4. And in general, everything will look fatter than it does now. So qualitatively, it'll look something like that. Everyone feel okay with that? And when in doubt, you can always, once you have a graph, go to a graphing tool, Wolfram Alpha, graphing calculators if you've got them, Maple, MATLAB, and sketch and just know what the graph should look like. Let you know if this graph is actually correct. So let's keep on trucking. So any questions about this example before I move on? / have I done anything that seems incorrect?
I was just wondering why it moves over.
Sure. So it doesn't move so much as it stretches, and it stretches away from the x-axis.
Okay.
So this point has moved over by 2, but let's think about this point. Which I think is the point 1, 2. So where will that point go when we do this transformation? 2, 2. So, okay, and I actually did it reasonably. So that's where the blue point goes. Do I really only have that many colors today? That's where I had purple. Ah, well. Let's trace one more point. So how about this one? So I believe that's the point 0, -1. You can't see that. This one's in blue also. 0, -1. Where is 0, -1 going to go when I do this transformation? it'll stay put. It won't go anywhere. It'll stay at 0, -1. Okay, so I missed. The intercept should still be at 0, -1. That seem okay? Yeah. So it looked like it shifted over, but in reality it just stretched. All of the structure we saw was to the right of the axis, so it looked like it was traveling right. Yeah. So, yeah, you know what? Let's do one last one. So here's 3 computer-generated graphs. And I believe -1/2 x minus 2 squared plus 3 is exactly the function that we graphed on the previous page. So by looking at the graph that you just generated, which of those 3 could possibly be the correct graph? The far left one? Cool. How do you think we could try to double check whether this is actually the correct graph? We could plug in some like x, y values, right? So, I mean, this is just a general multiple choice comment, which I tried to make an awful lot on that group quiz. If you don't have any ideas, use the guess and check method. Right, there are only finitely many options. If I give you no information and ask you to graph a function, you can't eliminate all infinitely many possible functions one at a time and hope to get the right graph at the end. But if you only have 3 to begin with, you're okay. So let's try to put this together with something that we've done in the past. Let's think about piecewise functions. So let's try to sketch the graph of this piecewise function. The function which is x minus 1 when x is bigger than 2. That is x minus 1 squared when 2 is less than x is less than 3, less than or equal to. And exactly 3 when 3 is less than or equal to x. And right, the way we do that is we graph each of the constituent pieces one at a time, and then we decide where we need each of those pieces. So let's graph each piece. Of those pieces, these 3 pieces, which one seems like the easiest one to graph? Y equals 3. What does the graph of y equals 3 look like? So horizontal line at y equals 3. So there's y equals 3. And let's even think about that. What x values do I care about that graph for? Well, what x values do I care about that graph?
Less than equal.
When x is less than or equal to 3. So because I only care about that when, x is bigger than or equal to 3. I only care about that starting at x equals 3 and onward, and I care about that quantity when x is exactly 3. Oh, well, that shading in black didn't really help much, did it? So I care about that piece of the function, including the endpoint. What's the second easiest graph? One of those things to graph. Y equals x minus 1. What does that graph look like? Straight line. What's its slope? What's its y-intercept? So slope of 1, y-intercept of -1. There's the graph of y equals x minus 1. For what x values do I care about that graph?
X is less than 2.
When x is less than 2. So that means starting at 2 and going back, I care about this one. Including x equals 2 or excluding x equals 2? So I'll put an open circle there. And the last one I want to think about is x minus 1 quantity squared. And let's think about that. Maybe you can just already picture what the graph should look like by starting with x squared, but let's go through all the steps. To get that picture, you should start with the graph of y equals x squared. There's y equals x squared. And how do I shift it to get x minus 1 quantity squared? To the right by 1. And I'll even try to have exactly right y values, at least at integer endpoints. What x values do I care about this graph overall?
2 and 3.
Between 2 and 3. So from there to there, and I think you just told me, but including 2 or excluding 2? Including 2. Including 3 or excluding 3?
Exclusion.
Cool. Everyone feel pretty happy? So now we'll just put those 3 pieces together. I know exactly where I care about each piece. So to graph the piecewise function, I'll graph each of the pieces. Happily, that endpoint, Chris. I've already screwed up and I'm using pen, so I can't erase. That's probably a mistake on my part.
Can you move it up a little bit?
Oh, yeah. That's a mistake that I can control for. So let's graph each of the pieces one at a time. So up here, I see the line y equals 3. And in fact, this point I'll even address as 2 comma 3. No, 3 comma 3. What am I doing? Before that, I care about the graph of this quadratic function, which appears to start at 3 comma 4 and go down to 1 comma 1. And before that, I care about the graph of y equal to x minus 1. What? That's 2 comma 1. I can't keep anything straight today. Well, I guess that's not different from any other day. Right, that should be the point 2 comma 1 that I care about. And then before that, I care about the graph of y equals x minus 1, which does something like this. People feel okay about that? Like I'm okay? Yeah. So you can combine all of this together. We know how to graph more complicated functions, which means we know how to graph piecewise functions that are built out of more complicated functions. People feel, how do people, well, any questions about this? Cool. So there's, yeah, you know what, there's time for one more example, and maybe I'll give you guys a choice. So here are 3 functions. Do all 3 of those look like functions that you know how to graph? So do you guys think you can sketch the graph of this piecewise function on your own? So we've got, with the time limit, maybe I'll give you guys 2 choices. The first choice is collaborate with those around you, sketch the graph of each of the pieces and then the piecewise function at large. And the other one is I'll keep talking for a little bit. How many people want me to go through the walk? Okay. I think that's few enough hands that I'll even encourage you to sketch the graph of the individual pieces at least, and then try to put it together from there, talking with those around you. So I'll just be quiet for a few minutes. So how do people feel about this graph? How do people want a few more seconds before we come together? Okay. We'll continue to be quiet. Be patient. Now let's come together so I have some time to think about the last page of the notes. So let's graph each of the pieces one at a time. What does the graph of the absolute value function look like? And over what interval do I care about that?
-1 and 1.
-1. And I think I want to exclude these endpoints for now? Or do I want to include?
Include.
Let's even address them. So I guess that was a 1, 1, that -1. All right. Negative x plus 1 quantity squared plus 1. That's a parabola. It's like a bowl-shaped thing. Does it open upward or does it open downward? Downward. Where is that vortex point?
-1, 1.
-1, 1. So a downward opening parabola with vortex at -1, 1. Look something like that. And where do I care about that function? Yeah, when x is less than -1, I think. So, oh, what is it I'm using? And generally, I want like an open circle there, but you'll notice that it would be filled in by that filled-in circle anyway. So, and what's the remaining piece is, yeah.
If one equation includes that point and then the other equation excludes, would you just remove the dot like in homework, or would you leave a solid dot?
I'm happy with a single solid dot still appearing.
Okay.
Yeah, so technically speaking, at this point, like, that would be enough information to know the graph.
That's what I was.
And what does the remaining piece look like?
The same thing on the other side.
The same thing on the other side. So it's still a downward opening parabola, but now its vortex is at 1, 1. And I care about that function when x is bigger than 1?
Yep.
Cool. That example go okay? People feel pretty good about this stuff? So let's do one last one that's all about transformations. So imagine this. Suppose f of x is this function. And suppose from that function, you want to sketch the graph of -2, f of 1/2 x plus 1 minus 1. And I know it says there that I want you guys to like collaborate and work on it, but I think since I just had you guys do that, we'll make some progress all together. We'll go for 5 minutes, maybe we'll have it done by then. So let's try to sketch the graph of this. Between all of the symbols there, what's the first one you should deal with?
-2.
The -2. What is that going to do to x values? Nope, what is that going to do to the graph of the function?
It's going to flip it.
It will flip it in which direction? Vertically, and then what will the 2 do?
Condense it.
Stretch it out.
Let's see, it's being done to the whole function. So that's like this thing that's happening. So all of the y values will be multiplied by 2. So it'll get flipped and then doubled in the y direction. So let's just try to trace out where all of these points will go. So this point right now seems to be at -2, 1. Where will that go after I do that manipulation to it?
So we multiply
-2, 3.
yeah, y values will get multiplied. So where will that point go? -2, because there's also a negative sign. So this point will travel down here. This point appears to be at -1, 0. So where will that go when you do this? It'll stay put. This point at 0, 1 will go to 0, -2. This point at 1, -1 will go to, yeah, the same letter. 1, 2. And where will that last point go? Cool. And now we can, right, it's all a piecewise linear function, so we can connect these points with straight lines. Y-axis, y-intercept won't change. X-intercept won't change, rather. So there's the graph of -2 f of x. And maybe I'll use that as a starting point here. So what's the next thing that we should do if we want to sketch the graph of -2 f of 1/2 x plus 1 minus 1? Deal with the +1 and the -1. How will that shift to these points? Left 1, down. So let's shift each of those corner points, left 1, down 1, and then put it together from there. So this will go left 1, down 1. This will go left 1, down 1. Left 1, down 1. Cool. So the last thing, apparently, is to deal with the 1/2 in front of the x. What will that do to all of the x values? It will, yeah, so it'll divide all the x values by 1/2, which is the same as multiplying all the x values by 2. So maybe just for emphasis, what did this one do? That multiplied y values by 2, by -2. This will multiply x values by 2. So I think we have just enough time to start. So this x value, which right now appears to be at 1, 2, 3, 1, 2, 3, -3, 3, where will it go at the end of this transformation? Say louder?
Can you shift the paper a little bit?
Oh, yeah, you want to see, yeah. So this point down here was at -3, 3. Where will it go when I multiply all the x values by 2? -6, 3. And then apparently there will be like something red coming upward from that. And at this point I'm a minute over. So I think I'll stop. Give those of you who need to hurry out of here a chance to hurry out of here. Do you guys think you can finish this one? Yeah. So we'll start with this example next time, though. We'll probably finish it really, really quickly, and then we'll do one quick checksum. Yeah?
You mean -6, -3?
Yes, I meant -6, -3. The y value is also negative.
Oh, yeah.
Thank you for catching that. Right, it's really hard to do some mathematics when you like write something down and then immediately walk